Postcards from a Dying World, the podcast. For more than a decade, I've reviewed over 1,000 books that are mostly science fiction, horror, and bizarro. This feed will feature bonus audio I have produced over the years, as well as a monthly digest of reviews based on what I've read each month, plus the occasional bonus material about my own fiction. Thanks for listening. Hello and welcome to Postcards from a Dying World, another special episode with a special guest that I'm really excited to introduce you to. In the astronomy world, he's very well known, but for those of you who come from the science fiction and horror world, he may be new to you. Konstantin Batygin is a professor of astronomy at Caltech, and he is we're going to get into all the astronomy and the things that he does. He's an expert in orbital mechanics, which I know some people might be saying, huh? Okay, well, we'll get into that later, and we'll talk about like why it takes a whole lot of brain power to be an expert in such a thing. Konstantin, welcome to Postcards.
Hey, David, thanks for having me. It's a pleasure to be here.
Yeah, so we're going to get into you as a person first and do some biographical stuff. I know you were not born in this country. You were born in Moscow, but you ended up coming here at 13 years old. But, you know, you did a little bit of time in Japan, right? Before you came to the United States.
Yeah, that's
right.
I
bet that had a huge impact on you growing up there. Your father was a famous physicist, so your parents were scientists too. So maybe let's start with having parental scientists. Did that get you on this track?
Absolutely not. You know, one of the things that I really appreciate still to this day about my parents is they applied exactly zero pressure on me to do, you know, anything other than the thing that I was passionate about. And they said, go and do the thing that you really want to do, and then it won't feel like work. You will just, you know, enjoy it, and you will do well at it. You know, and so I came to do astronomy and astrophysics. Really, I really fell in love with it only in college. So I don't really resonate with the usual story of like, you know, I've loved the night sky since I was 5 years old, and you know, the first time I saw a meteor shower, I knew I wanted to be an astronomer. I was like, at 5 years old, I had no idea that meteors existed, or really until I was like 20 years old, I had no interest in planets whatsoever.
Okay, so we'll come back to that because there's a lot of time in between. But your parents being scientists, they didn't pressure you to do that. But you did grow up in a really different culture than the one you currently live in. So I'm sure that had a huge impact because this is your formative years. And I know you're a musician and got into that stuff. Did that stuff come as early?
Yeah, so I remember when I first, I remember my very first time listening to Metallica and just like popping the Kill 'Em All tape into my Walkman. And it's just like, it's as if, you know, my brain wiring changed that moment, because it was at a time, I guess I was, I don't know, 10 years old, 11 years old, something like that. Like I was learning to play guitar, and I had learned a couple chords, and I could do sort of, you know, an A minor to an E major transition and back. And I sort of thought, okay, this is fine. But then just like, you know, listening to thrash metal, like, how do they play like that? How is this so awesome, right? And at that moment, you know, my interests entirely became, you know, music, and you know, I still carry that with me to this day. And in fact, our band, we're about 4 shows away from becoming the next Metallica. I can feel it.
Well, I'm a big Metallica fan. I'm gonna have to put you in touch with my friend Ryan Downey, who does Speak and Destroy, a Metallica podcast, because I bet he would love to interview an astronomer who's into Metallica.
I love Metallica.
Yeah. But the Metallica was a formative band for me too, obviously. And I'm old enough that my first Metallica record was Garage Days Revisited.
Yeah.
And I remember Day and Date for And Justice for All, but Kill 'Em All being your formative first record. Do you have riffs from that record that you still play every time you pick up the guitar?
Absolutely. Yeah. I love Motor Breath. Right. Motor
Okay.
Breath. Great
Yeah,
song.
that's a Dave Mustaine riff, I believe, isn't it? Or
Yeah, I mean, half of them are right
yes,
from
right.
that. Yeah. So it's interesting because like I guess it was 97 that I got into Metallica. So Reload just came out, but I didn't buy Reload. I bought Load, and I was like, is this the same guy singing? Because he sounds like a man
Right.
now, and that's not entirely true on Kill 'Em All.
Right.
So it was kind of that like yeah, I mean, for a while, that obsession became my life, and to an extent continues to be.
Yeah. Well, and I think when you find that record or that band that kind of strikes you like lightning, like that, you're never gonna turn away from, the power of those moments. For me, I remember very distinctly, uh, I think the record or the song that really hit me was For Whom the Bell Tolls, was like the
Mhm.
first like Metallica song that, and plus like for me, for as a guitar player, that the right hand of Hetfield and the down picking and nobody plays rhythm guitar in metal better than James Hetfield, especially back in the day, right?
It's true. I mean, because you have to. I think part of it is like you have to have a hammer instead of your hand for to play in that manner. I mean, that was one of the striking things, is that it wasn't using the guitar. Like, I think so much of his playing is not using the guitar as a guitar. It's like using the guitar as a drum set. It's like a drum set that counteracts Lars's drumming, which admittedly could occasionally use a little bit of help. So it sort of it beautifully adds to that. So I I agree, and I'm still kind of in awe of them. They've had their ups and downs, but the last album, like the Hardwired to Self-Destruct album, was pretty good. And by pretty good, I mean really good. I listen to it all the time.
I
So
think Moth to the Flame is even though it's like a big hit, I think the riffs in that song are just amazing, like very heavy and I'd say another down picker who might come close to Hetfield is Max Cavalera of Sepultura and Cavalera Conspiracy. He's almost as good as Hetfield
yeah,
at the down picking.
asymptotic, yes.
Yes. But so I imagine thrash metal was like a huge thing, but other genres of now. So when you got this Kill 'Em All, were you in Japan at the time, or you?
Yeah, yeah,
Yeah.
yeah. I was in Japan, so there were two bands that I was really into, and obviously one was Metallica. The other one was The Offspring, and
Mm,
still love The Offspring to this day. I don't know why, but I initially, just because all of it was just like people passing tapes around at my school. I had never seen a picture of The Offspring, and primarily like the way I got into The Offspring is we had a bit of a boxing club in a basement, like where I went to school, and The Offspring was Smash was like the continuous soundtrack,
mm.
right? And I don't know why, but I had assumed that they were all really old. Being I was like, these guys are really good, but man, like, can they it's like really good for them how they still play at age 80. And I have no idea why I made that assumption, because they don't exactly sound like, I don't know, it was a real
A weird
surprise.
connection you made in your brain, right?
Yeah, that's right. I was surprised when I like realized that those guys were not, like we're not World War II veterans.
Hmm. Yeah, right. And so, how quickly from that hearing Kill 'Em All did you pick up the guitar and get serious about it?
it's all I did every day, like in all free time. Sometimes I'd just cut school specifically to just play. And, like we didn't really have the means to, like get guitar lessons or anything at the time, but my dad played. And so he sort of showed me the ropes, so to speak. And the other thing is, I remember, I didn't have an electric guitar, but I had an acoustic one, and I couldn't figure out why it sounds drastically different from Metallica. And I also couldn't figure out what the words were, right? Like I didn't speak any English at the time. And so I remember in trying to recreate one, I was just like, I have no idea what the hell he's saying. I'll just write my own lyrics. So I wrote my own version of one, which
It's genius.
was horrible. I mean, it
Right.
truly horrible. Yeah, I think I recorded it on a tape at some point, and I really hope that's destroyed by now. Like I hope nobody finds it and
Blackmails you. Yeah.
well, it's just because you can't unhear it. I'm more worried for the damage it will do to whoever hears. But it's just, to answer your question, it was absolutely the thing that I was into, right?
Right. Well, and that's really cool, because I think about I got into to punk and metal and stuff around the same age, and I got into horror movies at the same time. It was kind of like simpatico thing. And I have a very funny experience with because I got very into Clive Barker. Clive Barker and Stephen King were my heroes, in the way that Metallica, like I became obsessed with wanting to become a horror writer, and what's cool is we both got these dreams. We made these dreams happen. And but I made my father take me in 1987 when I was in 7th grade to see Hellraiser, which of course anybody knows the movie's about sadomasochistic demons and all this stuff. And it was very hilarious to me to see his reaction. And of course, his reaction was, your sister's taking you next time.
Yeah.
But so now your father, who's a physicist with a particle accelerator, and what was his reaction to Metallica when you are like, help me learn this song? Because I'm sure you played it for him and said, Dad, help me figure this out. Right?
He was into it. Yeah, he was into it. I mean, it was different from what he had been into before, but he was 100% on board. And this is part of, I think, one of the requirements of being a scientist, at least a good scientist, is you got to be flexible about kind of what comes your way.
Right.
He was like, yeah. So I remember we figured out, and by we I mean really he figured out and showed me, how to play Until It Sleeps and Enter Sandman, and the few things that are palatable for somebody who's just starting out. So yeah, we
Enter Sandman, a Kirk Hammett riff, by the way.
That's true. True.
A rare Kirk Hammett riff.
That's right. Apparently there was an iPhone full of them that got lost at some airport. Like this was a whole thing circa 2015 where he was like, I had a full iPhone full of riffs and I lost it at an airport, which is, I've definitely heard that excuse from some of my students.
Right.
So written up,
But it does remind you to back up riffs, right?
Absolutely. Yeah.
So he took this in and was being a really good father and got into it with you. That's pretty cool. Yeah,
absolutely. No, I mean, like I totally lucked out in this regard. Like I have I lucked out with awesome parents. Both my mom and my dad are cool and are great people, and I actually, enjoy hanging out with them as opposed to the usual, the usual trajectory of how it goes, right?
Right. Well, and you said an interesting thing too that I want to drill down a little bit on, is that you said that at the time you didn't speak any English. So, and what's really interesting is that because you're obviously your English is amazing now, but So were you speaking Japanese in school or yeah, okay. Because I know a lot of, having been born in Russia. So at the time, were you speaking Russian at home and Japanese at school and like?
Yeah, that's right. So, I mean, I went to Japanese elementary school,
Mhm.
um, and when you're 8 years old, you just pick it up, right? Like we arrived in Japan in '94, went to third grade. In fact, I skipped second grade by virtue of being too tall because our school had some set of rules about how large versus small a child can be to fit into the desk because the desk kind of grows with you. And they were generous quotas, but I exceeded them. I was pretty tall, as a kid, and relatively tall
Still
enough.
pretty tall dude still.
Yeah,
Like,
so I got put into third grade, and it didn't really matter, right? Because I didn't understand anything anyway. But I remember this point, kind of half a year into just sitting in a classroom, not having any idea what's going on, where suddenly I was like, I'm starting to I think I understand what they're talking about. Like it was like this quantum moment where I realized that some of it is clicking. And that's definitely not something that's recreatable, at age, whatever, anything above 8, at age 9, that's already more difficult than age 8. Um, I've got an amazing story. Well, it's not an amazing story, but it's a funny story. So on the first day that I arrived to this elementary school, right? The
mhm.
first class they took me to was a music class. And I had like seen a guitar before because we had a guitar at home, and I had seen a piano, but that was it, right? And I would show up to this third grade Japanese elementary school orchestra, which is like the LA Phil, and so it's just like what is happening here? But then the class after that was a kanji test, and I kind of freaked out and decided I'm just going to copy everything that the guy next to me is writing. So I did my best to copy his test, and I turned it in, and I had copied everything, including his name, right? And I just kind of submitted that for review. Anyway, it was an interesting time, but absolutely would not, I would not say that it was in any way bad.
Well, what's interesting to me is that you grew up speaking Russian, then learned Japanese, and then of course had to learn English when you moved to Santa Cruz at 13. I'm wondering if that amount of learning languages when you're young, I think maybe makes the science and the processing that you go through something a little bit easier, that maybe like, it helps wire your brain towards these complex things like orbital mechanics. You know what I'm saying?
Well,
I wonder about that.
I don't know. I mean, I don't know that I have any more like innate ability to do anything than anybody else. I think the one advantage of kind of being moving around a lot is that you kind of get over your fear of new things, right, happening to you. And so I think that's more important, I would argue, than any form of brain wiring in science, right? It's more important to just kind of be okay with the constant discomfort of not understanding what the heck is going on, right? That's the whole thing. If you understand what's happening, right, you're not really doing that interesting of research.
Right.
So I think in that sense it has been beneficial. Yeah.
Yeah. No, I see that. So Santa Cruz at 13 years old.
Well, I
Yeah,
mean,
that's a big cultural shift, right? And probably led to getting involved in actually playing music with others, right?
that's right. It's the first thing. So like we started a band with a couple of guys, and that the bass player from our middle school band, I just had beers with him like a month ago, so we still keep in touch. It was so much fun. I mean,
That's
this
cool.
this was
Yeah.
one of the really awesome things about moving to the US, right? Like I couldn't really get a band going in Japan. First of all, we lived in this tiny apartment where with like paper thin walls, right? Nobody had a drum set. It's just like it was just not a thing that you could really do. And yet here we were in California, right? And people were playing punk, right? Everybody was kind of into it. So I started this band before I could really properly speak English. But you know, it was fantastic.
And what
And
was that first band? Come on, what?
it
Tell
was
us the cheesy
called,
name.
it was called No Release, and it was
Awesome.
spelled with a C to break the rules. I mean, that's the like
That's punk. That
that's
is
right.
punk.
We put out an album in in eighth grade called Munchies Crunchies Defiance, and I listened to it, I don't know, like a couple months ago, and it's awful, right? And right, it's just horrible, and the
Hey,
guitars are, yeah,
that's
no,
part of the process.
they're not in tune. But again, I think it's one of these things that are important to get over when, like, it's kind of okay to suck early on, right? And
Absolutely.
you're not going to be good at anything the first whatever 100 times you do it. So you got to get that that difficult portion of it out of the way as early as possible.
Well, Metallica's first show, they played more Diamond Head songs than they played originals. And, Hetfield didn't even play guitar because I think, I'm not sure if he intended to, but it was like they were pretty bad to start off. We all start off pretty bad, right?
Exactly. That's right. Is born being good, at music. Nobody's born being good at physics. It's so, there's kind of a, there's almost a comfort in it, right? Like in knowing that the first few times, whatever it is that you do, you're gonna be really bad at it.
Yeah. Did you guys do any covers or like
Yeah.
who would you say was your big influence in that first band?
Okay, so we did a cover of Santeria, Sublime, which was only marginally horrible. It was actually probably the best music we made. The other cover that we did that we actually put on the album was Buddy Holly by Weezer, and we at the time, being 14 years old or whatever, we said, well, what if Weezer comes after us and sues us for stealing their song? And so we came up with a solution to this problem, and on the album cover we wrote Muddy Holly instead of Buddy Holly. So we figured that way Weezer is not going to find out. I mean, it's one of these things that are that are so silly in retrospect. But I remember we were pretty serious about not getting sued by Weezer.
You thought, we tricked the system, right?
That's right, exactly.
And
Yeah.
did you now that you're 14 years old when you did that? Now, later in high school, did you do more bands, different
Yeah.
bands?
So
Like,
with the
what kinds
same
of
band-
music did you do?
Yeah, with the same band, we put out another album, which was better. Then we actually started a band with my dad called The Seventh Season. We played a ton of shows, and we put out a couple albums, one in 2003, one in 2007, and that was a lot of fun. So then we moved to SoCal, and the band sort of kept going. We played a bunch of live shows, but our recording, we basically went on hiatus. We recorded a bunch of stuff like in 2011, and so there's a whole album of material that I actually spent literally the last week finishing. And in the meantime, there's another album that we've recorded, which is currently in the process of getting mixed. So we'll be putting out a couple new things in the next year or so.
Now that's a wrinkle I didn't notice, was that your father is he still in that band with you, or just did time in it?
I mean, yeah, so the band is I mean, my parents live in New Mexico now, so it's a bit more tough for him to come out for shows. But we did a gig with him, a few years ago, maybe 2017 or so, and that was fun.
That's awesome.
Actually, during the pandemic, we recorded with my dad a bit, because going back to those 2011 primarily drum tracks and guitar tracks, and we kind of layered his bass on top and did a bunch of vocals. So in the band, the lineup is always kind of in flux, but it's all great people. Almost everybody has a PhD. So
that's awesome. Yeah, it's kind of like that band Stephen King did with all the New York Times bestsellers, like having all PhDs. And
now, Stephen King, I got to tell you, if he keeps this up, just one day he's just going to make it in this business.
Yeah, maybe. Yeah, if he's persistent, he'll maybe catch up to his son on that.
That's right.
Well, that is. I think it's really cool that your father obviously taught you how to play guitar, right? And played these moments. So that's really cool that you guys continue to play together. That's really neat. Well, it's cool that you're still working on the music and still. I'm sure. What's the balance like for having the academic life and doing the music, and then from there we're going full astronomy after this question, because I'm ready to go.
Okay, look, I mean, for me, those two really go hand in hand. I don't really have creative ideas in astrophysics if I don't play music, and I think the closest link between the two that has happened is the Planet 9 Symphony. So I became friends with Eduardo Martoret, who is the conductor of the Miami Symphony. And he, in part, inspired by, our work on Planet 9, wrote this amazingly complicated symphony. And we recorded it during the pandemic in sort of the distant way, where they recorded the symphony part in Miami, and I layered the guitars, in my home studio. And then we put it together and sent it to the International Space Station, where I assume they're just blasting it all day and all night long. I mean, I'd be offended if they were not, but that was
it is pretty cool. I gotta say, like it's one of the, I listened to it the other day and was just and it's funny because it is like a perfect synergy of this kind of thing. And it's really cool that these musicians were like, and they reached out to you and said like, hey, let's make some music for Planet 9.
Yeah, I mean, the whole thing actually came together in part, in large part, to give full credit where it's due to our mutual friend Helen, who is one of these people that are a catalyst to just things happening, right? I mean, it's so Helen was was kind of the coupling between all of us, injecting energy into the project, making sure that it happened. I have to say, like, I don't read music, and it was pretty hard, especially because some of the parts of the guitar are actually quite complicated in that symphony, right? So it was a challenge, and like with everything else, the first 1,000 times I played it, it was awful, right? But it turned out well in the end. I think really well, actually.
Yeah, it's really cool. All right, so you got into astronomy in college. You didn't love the night sky before that. You weren't into it. There had to be a moment where you were like, I think I can do this, or this is exciting, or now I have a passion for it. What was the seed that made you suddenly passionate about astronomy?
It was the realization that chaos is prevalent in astronomy. And here's the story. Like UC Santa Cruz, where I went for college, has these occasional, like, or at least when I was an undergrad, they have these, events where the undergrads are supposed to hook up with their like research advisors and kind of do work together, and you kind of get introduced. And my girlfriend at the time, who's now my wife, talked to this guy, Greg Laughlin, and then introduced him to me, because she was like, this is the type of guy that Konstantin would enjoy working with. So I got to talking with him, and he's an expert in astrophysical chaos theory. And we sort of got to talking about the fact that asteroids, right, like in the asteroid belt, right, the orbits of asteroids are unpredictable on long periods of time. And I said, wait a minute, like, what are you talking about? Unpredictable, right? Like, it's just gravity. How can it not be predictable? We know, the force is gmm over r squared. Like, it's trivial. We did the circular orbit like in class, on like the first class of physics. And he's like, yeah, it's actually not so trivial, because on long periods of time, small perturbations to the kind of starting conditions lead to these wide uncertainties. So the notion that planetary motion and just like motion of astrophysical bodies can be fundamentally unpredictable really resonated with me for some reason.
Right.
And, it was starting that moment, that became, my life in parallel with music. Right. I still not only enjoy it, but I still love it to this day.
Yeah. And so your thesis was the dynamical stability of the solar system. So,
right.
So what you do is basically, or in this thesis, you're talking about what makes the solar system basically, like, how can you look at the clockworks that happen in our solar system? That's orbital mechanics in a nutshell, correct?
Yeah, correct.
Yeah.
So it's the attempt to find solutions for, the long-term behavior, orbital behavior of heavenly bodies under gravity.
Yeah. So what you're basically the solar system and the function of the solar system is what you do, and that's how you ended up at Caltech, right? Because that's
right. So like, it's funny, we were playing so many shows in undergrad that like my grades were actually not that good, because I was just always doing homework, like backstage or whatever. But I realized I was pretty good at research, and I published a paper by the time I was applying for graduate school. And that was the only reason, that and a clerical error were the two reasons I got into graduate school. And so, coming to Caltech was amazing, right? I thought to myself, okay, this is not something that just comes along, randomly, right? This is an opportunity of a lifetime. So I worked really, really hard in grad school, right? I mean, I was in my office doing research like every day until 2 a.m, right? That was my schedule. Right. Again, because at the time I realized, okay, if I don't do this now, right, I won't have time to do it later, and also like, you're not going to be good at research for the first 100 times you do it, right? So, there's no real way of getting around, paying that cost, if you will. And it's good to do it, while you're young, while you're 22 or something, right?
Mm-hmm. Well, and I'm sure, and listen, I'm going to try not to make too many jokes about this, but you did end up at the department that the Big Bang Theory is, has made popular. But the reality, of course, is that you guys are doing insanely intense hard science, in reality. So I'm sure there's a difference between, like, when you go into that particular school with everything that's happening in pop culture, I'm sure that there was a certain degree of of jokes and things about that, and just in
No,
reality.
it's exactly like Big Bang Theory.
Oh, really?
Yeah.
Really?
And many
Okay.
people don't realize that that's a documentary. People think it's a comedy. It's actually a documentary series. Yeah.
Well, then I've got to ask, because my wife and I are both, we did like we got burned out on it. It was on enough years that we did eventually get burned down on it. But was there ever a moment on that show where you were just like, that is way too close to something that really happened?
Yeah, it's funny because like my wife also worked at Caltech, in a biology lab when I was in grad school. When we would come home and watch Big Bang Theory, and we were like, "Why are we watching? We're in this all day. We come home and we watch this on TV. Like, what is wrong with us?" Right?
Right.
So,
But there's a certain familiarity, right? Punk rockers want to watch movies about punks, and like, so that's one of the reasons why punk rockers like Green Room, even though it's like has a horrifying ending. But you're like, hey, I've been on tour and I've played in shitty places,
yeah.
and
That's right.
where
They call it a Tuesday. Yeah.
yeah, exactly. So okay, and then you got into like exoplanets and hot Jupiters, and so when you're stretching out and doing these different topics, now you're learning about more deeper forms of astronomy. And what are the more exciting things that you discovered once you got past the surface, when you started doing these different research papers? And what are your favorite kind of like hidden corners of astronomy?
Okay, this is so I've had a lifelong fascination with chaos, right? So I have a paper coming out with a couple of colleagues of mine, Rosemary Martling, who's in Australia, and David Nisworny, who's at Colorado, where we relate the behavior of Kuiper Belt objects. These are objects beyond the orbit of Neptune, sort of distant things, to what's called the standard mapping, which is a slightly obscure mathematical module, if you will, that you can use to sort of, it's like a toy model that you use to study chaos. And so that's something I'm very excited about at the moment. I have also developed a love for magnetohydrodynamics. So this is the behavior of kind of ionized or weakly ionized plasmas and their interactions, both as fluids themselves, as well as interactions with the magnetic field. That subject is beautiful. It's a beautiful thing. And the other thing that I've been really interested in recently is the question of how the satellites of Jupiter and Saturn formed, right? We've known that Jupiter has satellites for over 400 years, right? That's literally the first discovery ever made in astronomy, right? Galileo looked at the moon and looked at the brightest thing he saw in the sky, Jupiter, and found satellites. What we don't understand is why they're there in the first place. Our understanding of their formation is remarkably naive. And so I would say that, that's something I've gotten really into over the last couple of years. We have a paper with a colleague from France named Alessandro Morbidelli, where we've kind of proposed a new theoretical framework for explaining how the satellites formed. And so that's a cool problem.
Well, and if you're lucky enough on the right night and you've got your telescope on Jupiter and you can see like Io transiting or whatever. I was at a star party 2 years ago where I managed again to take some coworkers to it. And we were lucky enough that over the hours that we were there that night, we got to see Io transit. And the fact that, because you can look at Jupiter and it kind of looks static, but if you can see the moons moving over time, it just really sends home to people that this is movement that's happening. It's happening right now. And so I do think the formation or like whether it's Jupiter or Saturn, like these planets that have like tons of satellites, and knowing more, that's like a mini solar system, right? So like
exactly
in a lot of ways.
That's exactly right. It's
Yeah.
a miniature solar system. One really remarkable thing about it, to tie back to exoplanets, is that if you were to take Jupiter and the satellites and scale them up to the mass of Jupiter turning into the mass of the sun, and scale up the mass of the satellites in an according way, you would get the typical extrasolar planetary system, right? The typical exoplanet census is not the solar system, right? It's objects that are marginally bigger than the Earth. And by marginally, I mean factor of a few times bigger than the Earth in terms of mass. And they orbit their host stars with periods that go from sort of days to weeks, right? That's the common outcome of planet formation. By contrast, the solar system has nothing inside Mercury's 88-day orbit. That in itself, by the way, is a really interesting theoretical question. Why did the solar system turn out differently? And in general, right, the solar system being a relatively uncommon outcome of the planet formation process throughout the galaxy.
Well, that's new science, right? Too, because the amount of, I mean, we're discovering hundreds of thousands of exoplanets now, like all the time. And when Vera Rubin gets up and all that, it's going to be more, right? I mean,
well, I think for, where the census is going to be in the thousands for the foreseeable future. And Vera Rubin is going to be very good for solar system stuff, as well as like galactic stuff. For exoplanets right now, the key kind of discoveries are coming from the TESS satellite. Right. That TESS will eventually, of course, retire. But there are many missions that are coming online as well. There's Plato, which is a European mission, European satellite, kind of like Kepler, that's going to be coming online. So it's going to continue to be an exciting field for the next, decades.
Well, and that's a change, and science fiction writers like myself need to take note. That's a change that we're seeing, is that, we just kind of always assume when we're writing these other planets, we have to assume, we just assume, okay, well, there's 8 planets and there's a Goldilocks zone, or maybe there's 10 planets and there's a Goldilocks zone, and
no, actually there's 9.
Yeah, right. Yeah, I know when you're getting there. But we as science fiction writers, we always kind of we've been thinking in terms of like that the solar system is just kind of a normal common thing. But what you're saying is that we are weird. Like our solar system is unusual, like the way that the planets work.
That's right. And then it's unusual in a multitude of ways. So if you just, Poincaré, who was a remarkable mathematician, lived about a century ago, and both a philosopher, he often approximated the solar system as just the sun, Jupiter, and a bunch of other stuff that is not very massive. And if you take that approach, which is basically the right approach to take, then of course the giant planets, Jupiter and Saturn, are the main event of the solar system. Right. As it turns out, giant planets are rare. We don't quite know why. I mean, there's nothing about the core nucleated instability theory of their formation that should suggest that they form only rarely, but around sun-like stars, they're a 10% effect, okay? So 90% of sun-like stars don't have, the more common lower mass stars, things smaller than the sun, they're even more rare. So just by having the giant planets, the solar system already scores an A, right? It's already kind of in the top 10 percentile. And then you can go through and enumerate, other remarkable constraints, like the early solar system was enriched in aluminum-26, right? It's an unstable isotope, has a lifetime of 700,000 years, which causes many of the meteorites to differentiate. Like that is not a common thing either. Then you look at the Earth, right, which I think is quite an important planet for us to think about. The Earth did not form while the disk of gas and dust that produced the giant planets was around. The Earth formed 100 million years after the gas was gone, right? That in itself is a remarkable thing. That's actually we can do astronomy in the first place because we don't have this extended hydrogen helium atmosphere around the Earth, and the Earth
we wouldn't even know what was up there at all if yeah, we had a different atmosphere. Well, right. And so I guess that would give back up to Fermi, right? The idea to the Fermi paradox that if our solar system is so unusual, that could explain why there's a lot less life out there, because there's or at least like as we define or as we think of it, there's the whole concept of a Goldilocks zone, right, is even more rare once we actually look at the science of exoplanets, right?
Right. I mean, look, when it comes to the question of life on other planets, I don't think that's a particularly interesting question, because the answer is obviously yes, right? Like, is there life on? Of course, there's life on other planets. There's planets around every star that we know of, to a pretty good approximation. Maybe it's half the stars, but it doesn't really matter. The galaxy has 1 trillion stars, so even if only half of them have planets, there's a ton of planets out there, and it's a statistical impossibility that the Earth is the only place that hosts life. The sharper, and I would say more interesting question is, where's the closest life? Is it on Europa, right, the satellite of Jupiter? Is it little whales swimming in the oceans of Europa, or Enceladus, the satellite of Saturn? Or do we have to travel halfway across the galaxy to find the next kind of like DNA-based life? That question remains very much unsolved. What were we talking about? I feel like I went off on a random tangent, but
no, we were talking about how weird and different our solar system is.
Oh yeah. No, the solar system is weird. The Earth is special. Let's keep it clean.
Yeah, totally.
We've not been doing a good job.
Speaking of special planets and or dwarf planets, as they may be called, you and Mike Brown have you work with Mike Brown, who's kind of universally known as the Pluto killer, right?
Sure.
Yeah, and but the discovery of Pluto is very important to what you guys do. And I wonder, because the way I look at it, and you're probably going to laugh at me and be like, no, you're wrong, David.
I'm gonna laugh with you.
Yeah, okay. But my theory is that I still feel Pluto is a planet, but I think that if you're going to define it as a planet, there's hundreds of planets out in that part of the solar system. And it's just hard for humans to wrap their brain around that. They want it to be this nice small number, but really there's so many objects out there, right? That if we call Pluto a planet, then we have to call lots of other things planets. And I'm sure that
what's an island versus a continent, right?
Right.
Is Australia an island or a continent? Well, maybe it's both, but Australia, I think it's a little bit silly to really think hard about the definition of a planet, right? Because we don't have like a definition for what a guitar is, right? We don't have a definition for what a star is, right? Those are concepts that we understand very well, but we don't necessarily have to like delineate that a guitar must have 6 strings unless it's a 7-string guitar, and then it's a different kind of, right? It's just like, it's a useless thing to think about. Now with planets, what do we mean by planets? By planets, at least for me, what I interpret them as are things that play a dominant gravitational role in kind of sculpting the architecture of the solar system. If I throw, a hat into outer space and it orbits the sun, clearly my hat is not a planet. So that boundary intuitively lies somewhere, and it has to do with mass. The fascinating thing about Pluto is that when Pluto was discovered in 1930 by Clyde Tombaugh, they thought the thing that Clyde Tombaugh was looking for was a 7 Earth mass object, right? Something that was predicted by Parseval Lowell to should have been there.
When the discovery of Neptune happened, right?
That's right, after the discovery of Neptune. And when they found something, they assumed that, well, this must be the 7 Earth mass thing. Immediately, there was a problem where they looked at it and they said, well, for 7 Earth masses, it sure doesn't look big. So they said, well, okay, let's revise it. So now it's going to be 1 Earth mass, right? Because this is something that is perhaps not as widely known as it should be. When you're just looking at an object in outer space, you have no idea what its mass is, right? Mm. I mean, just like if you looked at a truck from far away, right, you could estimate its mass based upon its size, sort of, but you would get the wrong answer depending on whether it's loaded or unloaded. So similarly with Pluto, you know, its mass kind of kept going down and down and down until 1978, when its satellite Charon was discovered. And then it was like, oh boy, this thing is 500 times less massive than the Earth. In fact, its surface area is almost perfectly equivalent to that of Russia, right? Now, like, you know, Russia is big, but it's not a planet. Although it sort of is its own planet, but it's you know, my point here,
13 time zones is still a lot, you know. Yeah,
exactly. So I think it's interesting. Like, I did not know the history of Pluto's discovery until all this Planet 9 business you know, caused me to really look into it more deeply. But it's fascinating. And you know, if you were to kind of stop your plot at 1978 and kind of track Pluto's mass, it was clearly on track to disappear by the year 2009 or something, where its mass, because it was going down so fast, you know.
Right. Well, but so for the listeners, like, one of the reasons why you were on my radar is I went to see you do a lecture at San Diego State a couple of years ago, and something big happened with Pluto since that lecture. Which is that New Horizons did its pass of Pluto. I'm wondering, did New Horizons making its pass of Pluto really affect? Did you guys learn anything that was helpful for the Planet 9 search with New Horizons, or?
No. I mean, New Horizons data is remarkable in its own right. It has nothing to do with Planet 9. What it really revealed is that Pluto has geology which looks like the Earth's geology, right? And this is because geology is really a physical process, tends to recreate itself at different temperature scales, because on Earth we have obviously water ice, and water ice flows at temperatures relevant to Pluto that are like 40 Kelvin or whatever. Water ice does not flow at all. It basically behaves like metal. But you know, CO freezes out and then CO flows. So you can have a lot of the same phenomena, glaciers, and just like remarkably cool terrains that recreate themselves on these dwarf planets. So that in itself is beautiful and scientifically interesting, but it's a separate problem for Planet 9.
Yeah, and I just realized that a lot of my listeners are people who don't know what Planet 9, what we mean by Planet 9. But so probably the biggest research project that you're involved in, and the thing that you're most famous for doing, is you're working with Mike Brown at Caltech to basically using the same kind of science that the discovery of Neptune kind of led to finding Pluto, is that when you guys looked at crunched the numbers of the orbital mechanics, you believe that there is a 5 to 7 times Earth mass object out there in the solar system that we haven't discovered yet, and that you're calling Planet 9, and that you guys are looking for. And what I think is most interesting about this too is that it operates in all kinds of different ways. But the thing that I always find is funny is that you guys have said, and correct me if I'm wrong, 98.2% certain that it's out there. That's a pretty firm number, right?
Yeah, we have an update on that actually. So it was 99.8, but it has, we've redone the statistics in a slightly better way, and it's gone down to 99.6.
Okay.
That's in the upcoming
That's a
paper.
firm number though, that
Yeah,
you're
so
positive it's out there.
okay, so to be clear, what this number represents, that's the kind of 100% minus that number, the 0.4%.
Yeah.
Is the false alarm probability that the orbital patterns that we see in the night sky are not real. Okay, that's the probability that we see them by coincidence, by observational bias, by basically by virtue of getting unlucky or perhaps lucky. So this does not equate to the probability. This is not the probability of Planet 9 per se. This is the probability of there being a gravitational signature of something being out there. One of the really interesting things about the calculations that we do, and one of the really unfortunate things, is that we can never, based upon the methods that we use and the data that we have, we can never tell you what Planet 9 actually is. It can be a 5 Earth mass burrito. It can be a 5 Earth mass planet, a 5 Earth mass glass of wine. All of those things will produce the same gravitational signature. In fact, it can even be a 5 Earth mass ring of material. Our models will not distinguish between all of these options. But just if you kind of consider what is astrophysically most reasonable, right? In that mass range, the only thing we know certainly come in 5 Earth mass.
So pardon my science fiction brain, because I am a science fiction writer. Could it be a 5 mass black hole or wormhole or something that
the black hole thing has been proposed by some colleagues at University of Illinois. Black hole, the standard way to make a black hole is you wait for a star that's more massive than 1.4 solar masses, roughly speaking, to collapse under its own weight, basically run out of fuel that keeps
juice?
it. That's right, exactly. And then create a black hole. So the standard black holes that come sort of from stellar evolution are much more massive than 5 Earth masses. But during the Big Bang, it's one of the kind of predictions of inflationary cosmology is that you produce a whole spectrum of black hole masses, including 5 Earth mass ones. Now, you can ask the question, how likely is it that the sun has a binary black hole, attached to it? And I think that's an interesting calculation to do. But, as far as we know, if it was a 5 Earth mass black hole, everything about our calculations would work identically.
Interesting. And because everybody has this concept of the black hole kind of pulls everything in and but it would just cause the same kind of orbital mechanics that your numbers account for, right?
Exactly. So, what we call the metric, which is the general relativistic way of saying gravity, basically. The gravity of a black hole is no different than the gravity of a non-spinning star. The sun's gravity, if the sun turned into a black hole tomorrow, in fact, this is a GRE physics question that comes up all the time. What happens if the sun turns into a black hole tomorrow? What happens to the Earth's orbit? And the answer is nothing. It'll be dark, but the orbit will be identically the same.
Interesting. All right. I'm going to use a Metallica analogy for your Planet 9 search. Okay. So you guys right now, it seems like for the last couple of years, you've been searching for Planet 9, and it's like if Cliff Burton got his first Kmart bought bass guitar and now soon he's going to get his Rickenbacker and he's going to be able to play
Sorry, I think you either broke up or muted yourself, or Cliff, the ghost of Cliff Burton, like was like, whatever you're about to say next is not going to work.
Okay, my connection was unstable for a second. Do you hear me now? Fine.
Yeah, I hear you now. Yeah.
Okay. Yeah. The ghost of Cliff was definitely messing with my analogy. So imagine it's like Cliff Burton going from the first bass guitar to the Rickenbacker with you have great telescopes you guys are using right now, but you're getting the really good stuff soon, and it's going to make a huge difference for your search. How hard is it? Because what people have to remember is if you're looking even for a planet like Pluto, or if you're looking for your Uranus or Neptune, they're so far out from the sun that they don't reflect light. Like when you see Venus in the west tonight, right? It's so close to the sun. That's why it's so bright. But these objects far out there, they're not reflecting a lot of light. So it's hard to find it. Like how is the game changing soon?
Yeah. Okay. So look, first of all, I appreciate you bringing that up, because I think it's hard to convey just how dim Planet 9 is. It is, I think, 100 million times dimmer than Neptune, right? And Neptune itself was not discovered until the mid 1800s, and for that you need a pretty significant telescope. The game is changing in the next couple of years because the Vera Rubin Observatory is coming online, and that's going to be that's right, yeah, doing a very efficient search of the night sky, kind of scanning things up and down, and it's got great sensitivity. Its sensitivity is actually not as good as the Subaru telescope that we are using, but what it really brings to the table is the efficiency of the search. Because when we do our search, first of all, astronomical time, like time on the telescope, is hard to come by, right? It's not like you can just show up and say, well, I'm using it tonight, right? You get a few nights a year, okay? And if the weather happens to be bad, you just don't collect any data, or fog rolls in, you don't collect it, you collect bad data, or the upper atmosphere gets turbulent, right? Things that you really can't, account for or predict.
Or Elon Musk puts up some satellites, and
yeah, that's another problem. So, at the end of the day, right, our search, I think, is one that's rather inefficient. We do our best, but at the end of the day, like, we don't know if we've already covered the part of the sky where Planet 9 is, but we just didn't find it.
But what Vera Rubin's going to do is just create data that you can look at over time, where it's basically taking a snapshot all the time, right? And got it.
Yeah, it opens up every night, does its thing, and then closes, and then repeat, rinse and repeat. So this is going to be pretty revolutionary for the outer solar system, and I think that's going to be really cool.
Right, and because there's more than just Planet 9 to find out there. There's all kinds of really interesting things in how the Oort cloud works, and
Absolutely.
that we just don't know. And yeah, it's amazing we've got Voyager out there, but it wasn't really designed to do to send us a lot of information back, and for example. But now here's another thing about Planet 9 that I find super, super fascinating, that gets close to the science fictional brain, right? And it's one of the things that makes the ideas of Planet 9 somewhat controversial. Is, so as I understand orbital mechanics, and I could have this wrong because, again, I'm just a fan, right?
So am I. I'm only doing orbital mechanics as a fan too.
Right. So the planets are kind of in equal in a plane, right? Where we're a little bit up from each other, a little bit down from each other, but we're all basically going around the sun in the same kind of path. But you guys have this theory that the numbers kind of put Planet Nine on a completely different trajectory. Am I right about that, or am I?
Absolutely, yeah. So Planet Nine is orbits the sun with an orbital period of about 10,000 years, right? Which is up from the 164 years of Neptune. Its orbit is considerably more elliptic, right? So it's got a out of roundness, an eccentricity of about 20 or 30%, maybe a little bit more. And finally, its orbit is inclined with respect to the plane of the solar system by about 20 degrees. Now, is that weird? Of course, it's weird if you just make the kind of standard projection of, okay, we've got the Earth and Mars and all of these things are on pretty circular orbits. But it's actually not that weird if you compare it with the extrasolar census of planets. Most
That was my next question.
yeah, the extrasolar planets that are long period tend to be highly eccentric, and so in that regard, it's maybe not too surprising.
Do we find exoplanets that have totally different kinds of orbits in the survey? Like, yeah.
Yeah. So I feel I forgot the license plates, like HG16 blah blah blah. There's a bunch of numbers B, which is a exoplanet which has Planet 9 like orbit. So that one was just discovered either this year or last year. I don't know. The pandemic is all one day and simultaneously like 400 years, so
right.
But yeah, so it's weird things happen once you get further away from the sun. Part of the reason for that is that early on, when solar systems are being born, they're not born in isolation, right? They're born in clusters of stars that are maybe 1,000, 3,000, 10,000 stars all forming together. And so once you get far enough away from the star, from your host star, you can start to feel the perturbations from the passing stars, and that can perturb your orbit significantly. That's one way to explain why Planet 9 is there in the first place, if you will.
Now, okay, before we wrap up, because I've taken a lot of your time and this has been super awesome. But I want you to try and I want to try to get you to flex some speculative muscles here. Right. And I know that's hard for some scientists to do, but you're also a musician and creative guy, so I think you can do this. But I'd like to imagine, and I know you guys have to think about after you find Planet 9, because if you're 98 or 99.2% or however much your numbers, sure that you're going to. Once you find it, what are you most looking forward to studying about this object, given that the statistical probability is that it's a planet that is much bigger than Earth? Like, once we find it and can actually like calculate and put a telescope on it on a regular basis and look at it, and maybe a long time down the line send a New Horizons type craft towards it, what do you expect to find? What do you want to find? What do you think is out there?
So there's a whole range of kind of day one projects that we've thought about. One that I'm maybe most excited about is the possibility that it has satellites, right? I mean, there's no reason to suspect that it does not. Satellites are not like some weird outcome of universal chance. They form through the same physics as planets. So thinking through about the possibility that it has satellites, what was the tidal evolution of these satellites like? These kinds of problems are really exciting. The other, of course, very basic question is, what is Planet 9 made out of? What does its spectrum look like? What does its atmosphere look like? Because, as I've mentioned already, the most common outcome of planet formation is not the Earth. As far as we can tell, it's not Jupiter and Saturn. It's sort of 5 Earth mass objects. So if we discover Planet 9, within our lifetime, and I sure hope we will, that will be the closest window that we will have to understanding what planetary bodies throughout the galaxy look like, right? That's going to be our closest link to extrasolar planets. So,
because it's so far away, it's so different,
well,
right?
it's also in the right mass range, right? It's like, the Earth and Venus and Jupiter and Saturn, Uranus and Neptune are different. They're not the most common type of planetary body that we found orbiting other stars. Planet 9 very much falls into that correct range of mass. So I find that to be quite remarkable.
Okay. Now, um, I asked the same question of the guy who used to be across the hall from you at Harvard, and but I want to ask you too. What are there ideas in astronomy that one day you hope to come back to that might be so far out of the box that you're just really trying to it's something that I'd like to do, but I almost think it's almost too speculative to do. Like, are there things that maybe in the future that are weird now that you hope one day will come closer to the circle?
No, I understand.
Center.
I understand what you're asking, but really, the answer for things I'm interested, no. I never worry about something being overly speculative or overly weird if the laws of physics take me someplace, right? Then that's where they take. I think that one of the kind of almost responsibilities of a good scientist is to on the one hand be very self-skeptical. On the other hand, when the options run out for the kind of alternative, for the simple explanations, if things don't make sense, then you pursue the thing that is weird and unexpected and might end up being controversial, and it doesn't matter because this is what we're paid to do, right? The agreement, right, is that we will use a little bit, a very small fraction, truly a minute fraction of your taxes to try and do amazing things. And if we don't do amazing things with it, then we're not, carrying out our end of the bargain. So I think that, I have.
And you said that chaos is what fascinated you, and like understanding the chaos of how it works, you're gonna find weird aspect. I mean, Planet 9 itself is a weird well, Pluto was a weird thing. That's why in 1936 or whenever they found it, it was so hard to find because
it was unexpected.
It was unexpected, yes. And then over time they become less unexpected. I'm sorry, but you're right. That is the mission that you guys do. So, all right, so let's get into how people can find your music first, because that was the first topic. How can people find your music online? What's the best way to do that?
So look, we haven't put out a new thing since like 2007, but we will be putting out a couple new albums, like I said, over the next year or so. And the website of our band is the 7th season.band. You can also follow me on Twitter at Batygin. I usually post band stuff. We're on our band is on Instagram at the.7th.season. Where else do we do? I guess we're on Facebook. I don't know if people still use that.
I do.
Yeah. Okay. So we're on Facebook. We're on that. We're on SoundCloud. We're everywhere. We're peaking, right? We're like,
yeah.
That's right. So look, I'm, like I said before, I'm really, really, really excited about the music that we'll be putting out in the next year. It's been a long and really fun effort to put these albums together, and they're good, or at least I think they're good, and my wife thinks they're good.
Well, yeah, you have reason to be proud of. You've worked your butt off on it, so yeah, and so that's where people can find your music. Now, they could also go to your Twitter to find. You do post about your research too. I follow you on Twitter, and sometimes you post like pictures of orbital mechanics numbers, and I just go, whoa, I have no idea what's going on there. But I know you're doing good stuff. But that's where people can find a lot of that. But do you guys have a center for finding the Planet 9 research or any of that?
Yeah, we sort of have a blog that's not very well maintained. I think it's findplanet9.blogspot.com. But really, most of the stuff that I post about Planet 9, I just post on Twitter. I'm not a good Twitter citizen or whatever. I don't post, I guess, often enough. But when stuff comes out, when new papers and stuff come out, I try to be at least marginally diligent about putting together little explainers about what this all means. So I try to do that kind of thing.
Yeah, no, and you do good outreach, and like I said, the SDSU lecture was what put you on my map, and I think it's good that you were kind of going out and doing these kinds of things and talking to the public. It was a really packed room there too at San Diego State. I was impressed with how many people turned out.
Yeah, it always it always is humbling, to have people come and kind of be there to listen to you ramble on about the outer solar system. I'm always amazed that as many people are interested in astronomy as there are, but I think it's also a testament to how how much just we all as humans resonate with curiosity. You know what I mean?
That's right. Yep. Well, and we look up all the time, and it's fascinating to it's one thing to see the night sky, but to understand even in little tiny ways how it works is just fascinating.
Totally.
All right, Konstantin Batygin, you were awesome. I'd love to have you back at some point too. Maybe hopefully with some good news about Planet 9 in the future. And I really appreciate the time. I think listeners will really enjoy this. And go buy his album when it's out. And thanks for listening.
All right. Thanks, David.